Hello, hello.
Hello, how are you?
Good evening.
Fine. Thank you very much, Öykü, for your invitation.
Thank you for accepting us.
So I only wanted to turn on the light conditions are quite fine, is it?
Yes.
Good. Now we have a little bit. Yeah, but really nice. So I was so happy when I heard from you that you founded Scientific Communication Society. At that moment, you can imagine my heart beat a bit very high. This is really nice. From which department are you, Öykü?
I'm from MBG, Molecular Biology.
Mm-hmm.
And Asaf is from
Physics.
Physics. Nice. Nice. So you both were in fact, the founder or the initiators of that, or
Yes. There are two other members, and they're going to come in a minute. But yes,
there are lots of founders actually.
Yeah, super.
They will come, and of course, all of our members are founders of this club because.
Okay. Cool.
Yeah. Our first semester.
Yeah. Very interesting, very fine. May I ask you, how did you get the idea? Was there a special event, or how did you get it? The idea to found this society.
Yeah, it was actually an event, but before that, we have met in an event from our friend. It was a mathematical philosophy. He was teaching us the mathematical philosophy in Bilkent under another club's name. Then we met, then we started to talk about science with each other. We tried to communicate with each of us. I tried to teach MBG, they told me physics. Then one day, there is a student of MBG. He is now at, what was the name of the college? I cannot remember, but in Germany, he is doing a PhD, Veli Uslu. He graduated from MBG department in Bilkent.
Nice. And in which university is he studying the PhD?
I will check right now.
It's Heidelberg, right?
Heidelberg.
Yes, Heidelberg. Yes. Yeah. Then
I was graduated in Heidelberg as well.
Oh, nice.
Okay.
Yeah, and for MBG, Heidelberg is a fantastic address, really premium address. So there is the German Research Center for Cancer Research. So it is really a huge capacity, really cool. Nice.
I'm dreaming of Germany too.
Yeah.
Yeah.
Nice. Yeah. Good luck.
Then he gave us a talk in one of our MBG seminars. He tried to told us about the science communication. He was one of the founders of science communication in another place. Then he won awards in science communication and etc.
Wow.
Lots of things. Yes, he is very good at this. Using Twitter is he's nice, popular. Then we got the idea. I sent the video to my friends. Then they said we can do this, and in Bilkent it was a necessity that we cannot communicate with each other through sciences are all separated from each other. It was one of the reasons, and others we cannot communicate with our teachers in a nice way. We cannot communicate with our people who they do not know science, and our political is not within the science. They are talking about pandemics, but they don't know about the virus, etc. All of these reasons made us do this.
Yeah, fantastic. Congratulations. And again, thank you so much for your invitation. It is a really very big pleasure to give a little introduction from my point of view to science communication.
Yeah.
Yeah.
Thank you for coming.
Yeah, should we start or?
Yes, we can start. There's a crowd already.
Okay. First of all, for those who are taking the GE 250 or 1, they can write their student numbers to the chat and their names. Thank you. You can start.
Perfect. Yeah, okay, then I directly start if you don't mind, or do you want to give a little introduction first, or Asaf?
Do you like it, sir? Do we have you like it?
You can start, I think, yeah.
Okay, cool. Yeah, ladies and gentlemen, again, first of all, thank you very much to Öykü and Asaf for inviting me to this little presentation, and all the best. I'm really happy and a little bit proud that you founded a scientific communication society, because according to my understanding, this is the very most important thing, the most important topic when we think, especially in the context of which kind of problems we are facing today. So on the one hand side, the pandemic crisis, but a much more long-term problem is the climate change, what we are facing too. And at that moment, it is so important that we all understand each other, the scientists among each other. This is what Öykü already mentioned, but it is also important that the public understands us as a scientist as well, because, and this is what I would like to develop a little bit in my presentation, it is important that we are aware that the public is not only the receiver of scientific information or scientific knowledge, they are also a part, an equal part in the process of innovations in a sustainable way. So my idea is, everybody, I don't know if someone is here who already followed or listened to one of my lectures or presentations. I'm a type, I like it very much to discuss. So of course I will give you a presentation, but at that moment when you have questions, or if there is something where you don't agree or you want to discuss it deeper, please directly interrupt me. I like it very much to get in touch with you, to get the discussion with you. But of course, I'm sure when I understood Öykü right, we have after my presentation also a little bit time to discuss certain topics more detailed. Yeah, so I'm switching always between the presentation mode and the, let's say, gallery mode, because I like it very much when I see the faces, or at least the names of the people who are listening to me. So therefore, sometimes I interrupt my presentation folders or slides, and I come back to the gallery mode. So I chose as title the title, Let's Talk About Science, Best Practices of Storytelling and Science Communication. And this title should lead directly to, yeah, let's say, private tragedy. So in fact, the typical situation, what I faced, and maybe you know this as well, you come home or you meet, and at home your parents or your grandparents invited some friends, and they are directly asking you, what are you studying, and so on. And when I said, so, oh, sorry, before I start with this story, I have to introduce myself. I'm sorry, I forgot. So graduated at the University of Heidelberg. I earned my PhD in chemistry there, and later I studied also media studies, and I had a second PhD at University of Bonn. And when I would ask you, guess what is my favorite subject at that moment, I think it is not that difficult to understand that my research interests are science communication, and in this context, especially visual communications. My PhD thesis in media studies was about information graphics, because there was a big change in understanding what information graphics are. We know it basically as pie charts or bar charts and so on, Excel tables made by Excel tables. But it is in fact much more embedded now in a broader context, especially when we think in the context of social media. So this is in fact the situation. How are information graphics understood? But this is not what I want to talk too detailed today. I talk more about science communication, and now I would like to tell you the story, the private story, which I'm sure you know these kind of adventures as well. You come home, your parents or grandparents have their friends there, and they ask, what are you studying? And when I said chemistry, and they go, wow, super, this is so great, it is so difficult, and wow, mashallah, and so on. And my brother, I have a twin brother, and when he was at the same time at home, he said, yeah, I studied music, and I'm now producing documentaries about classical music, and I'm collaborating with the Berlin Philharmonic Orchestra. At that moment also, oh wow, and so on. And they directly talked about, it's interesting, yeah, I know the Berlin Philharmonic Orchestra and so on. And then they asked, by the way, what was your theme? What was your subject in chemistry? And then I said, yeah, my subject was the transport of polycyclic aromatic hydrocarbons in soil under the influence of surface active media. And at that moment, silent. So, and because at that moment, when my brother was there, at that moment, they directly talked about Beethoven, Mozart, Mahler, Brahms, Bach, and so on, just to overcome a little bit the silence and the shame that they didn't understand. Is here someone who has an understanding, or at least an idea, what was the core idea of my research topic? Is there someone who understands that, or at least can guess what it is about?
Can it be about agriculture?
Not that bad. It was not about agriculture, but I guess your idea was because I'm talking about soil, right?
Yes, and also we are talking about hydrocarbons, which can be organic, but maybe this is something you produce artificially.
Yeah. In fact, a very good situation. It's about hydrocarbons, but polycyclic aromatic hydrocarbons are called PAH. Maybe you know this abbreviation. This is, in fact, the very most of them are poisoned in really ppm dimensions. So, polycyclic aromatic hydrocarbons is generated always when organic substances are burned. For example, in tobacco, when you burn cigarettes, at that moment you get it. When you burn coal, you get it, and when you burn oil, and so on. And especially in the context of coal power plants, the soil is poisoned by that. And at that moment, the question is, how can we decontaminate these soils? And therefore, the easiest way, of course, is we take the soil and we burn it. At that moment, you can be sure the polycyclic aromatic hydrocarbons are burned. So maybe you know that when you organic substances, when it is only hydrocarbon, as you already understood, at that moment we are producing carbon dioxide and water. Great. But what is the problem at that moment? what is, when we burn the soil, what is in fact the product of that? What we get? It is sand. So we don't burn only the poison at that moment when we burn everything and decontaminate it in this way. At that moment, we also destroy the humus matters. So which is very important for fruit, that the soil is fruitful. Otherwise, we are producing a desert. Creating a desert. And this is what we don't want to do, and therefore I wanted to know if we can do it with within the scope or with help of surface active media. What are surface active media? There's a short form, an everyday word about that: soap. In fact, it is just soap. You know, soap has the talent, or in fact the skill that it is. You can solve it in water, and it takes inside also oil. That's why we use soap when we wash our hand. At that moment, it is free of oil, or when we think on detergents for dishes, at that moment the same effect. And I wanted to know if are there soap which takes the polycyclic aromatic hydrocarbons inside of the micelles and keep the humus matters inside of the soil. This was in fact the idea. So, and when you now, I hope you understood it a little bit. So, but when we at that moment explain it with everyday words like soil, poison, soap, and so on, at that moment it becomes easy. This is in fact the question: how can we talk about science that the most people understand that? And this is in fact something what we have to learn somehow. This is what I told so. And at that moment, in these kind of adventures, let's say, private strategies or so on, what everybody knows, in fact, we realize that scientists are a little bit like wizards. You have an audience, everybody's interested in that, and then you start talking one scientific sentence, and it is like abracadabra and and magic. All people disappeared. Wow, how great. But this is, of course, not something what is our aim. So it is magic somehow. But in fact, what we want is that everybody stays at least till the end of the presentation to listen to that. And the first what we have to understand is, why is the situation like this? And a very good friend of mine in Germany, he reads a lot, and he said somehow he compared it the scientists in the way about the story of the seeming giant. It is in fact based on a story from Michael Ende, from Jim Knopf and Lukas the locomotive driver, in Germany a very popular children's book author. Maybe you know him. There is a story, it is called Never Ending Story. This was also produced as a movie, as a Hollywood movie. Maybe you know it about him about that, or Momo or whatever. No? But it can be that he is, especially in Germany, very popular. No? So Jim Knopf is a little black boy, and Lukas is a locomotive driver, and they lived on a small island called Lummerland, and after a while they realized they have to save the world, and they went out and had to manage many problems, and once they met Mr. Tutu in the desert. So in the middle of nowhere there was a giant, and he made some gestures. Oh. And they said, so it looks a little bit threatening, and maybe not a good idea to come closer, and a good idea to escape. And then they run. But after a while, they said, we are stupid. He makes one step, and at that moment, he reaches us. They turned back, and they said, these kind of gestures were not to threaten him. It was, he wanted to say, come closer. And then Lucas and Jim said, yeah, let's try it. What can we do? We anyway can't escape. And then something extremely interesting happened. The closer they came, the smaller the giant became. And when he was one meter or one step away from him, at that moment he was at the same size, so they could talk on the same eye level. So interesting, nice story, and he talked a little bit about this. So, and he said he's so lonely, and like later, Jim Knopf and Lucas, the locomotive driver, said, yeah, then come to Lummerland, and you can be, how is it called, the tower at the coast, so with a light, that the ship do not get, that they don't crash on the coast and so on. And this was his job afterwards. So first of all, the seeming giant, or the pseudo giant, however we want to call him, can it happen? Can it be? Is it really possible? And the scientists, of course, Asaf, I'm sure that you will agree with me, of course not. So it is definitely contradicts all physical experiences what we have. The closer someone comes, the bigger an object becomes, and when we go far away, at that moment it's but small. Definitely, for sure. And I totally agree. Even as a chemist, I say, yeah, I'm sure Asaf is right. But when we now think a little bit outside of the box of the sciences and have a look on the sciences itself, at that moment we see the science itself, the natural science itself looks like Mr. Turtur. Now, the further, when people are very far away from the subject, at that moment it looks very big, very threatening. Oh, I never will understand it. It is better not to deal with this. Hopefully my physics teacher do not ask a question to me. I have really no idea about that. And the more you deal with the subject, and when you find a way, when you get the courage that the giants, the scientists say, come closer, and you really say, okay, I come closer. Now, at that moment, you feel that it is not a big issue. First of all, you have to understand scientists are nothing else but human beings as well. They are very, at that moment when you discuss, when you communicate with them in a very easy way, at that moment people realize, wow, I can do it. It is, in fact, something what I can do. And the best situation, of course, at that moment is when you attract the people and say, cool, I want to study this as well. And this is, I'm sure you have these experiences when you are from science, from faculty, from science faculty or engineering or something like this. At that moment, I'm sure you have these kind of experiences as well. So there are too many people who do not study it, not because they are not interested, because they had no opportunity to discover how interesting it is. And this is why science communicators, what is in fact the main task of science communicators? How can we manage that? And now I would like to talk a little bit about science communication in Germany, because science communication in Germany did not have such a big tradition. There's a quite big tradition in the United States, in United Kingdom, and so on. So they had in a very early stage books, highly scientific books, but where they placed some little stories sometimes, so they did it somehow enjoyable and so on. German, a little bit according to their image, so Italian call German squareheads, and I understand why, because scientists are like this. So, oh, I'm a capacity. They said very often, yeah, when a young person from a school has a question, they are always welcome to come to my office. Yeah. Now think about with the head of a young girl who has really a question, how big the step is to go to a university campus, to go to a professor, knock on the door and say, "Hey, professor, I have a question." This is in fact a very big step. Right? This is in fact somehow a misunderstanding. Science communication does not mean only to open your arms and say you are very welcome, hoş geldiniz. It is also important that the scientists are going to the public. They have to be active to go to the public. And this was in Germany very long time misunderstood. The scientists lived somehow in an ivory tower and felt very comfortable. They got the money for the research and peer education, fine, and so on. But in fact, they didn't feel any need to communicate to the public. And what was the result? The result was that a little bit before the year 2000, the numbers of students in the STEM subjects, the science, technology, engineering, and mathematics subject, were dropping dramatically, really dramatically. And so only a few people wanted to study science, and one of the reasons was very obviously the Mr. Tutu effect. And the problem became so big, so relevant, because there was a dramatical lack of young talents. And even today, Germany can only bridge the gap, the knowledge gap with foreign scientists. It is now, after 20 years, a little bit different. So it is going to become balanced, but we still have a gap of nearly a whole generation who didn't study it. It was also, the beginning of the hype of new media. Everybody created websites and realized, wow, I can earn so much money. Why should I study physics or chemistry or whatever, only to do that? No? And at that moment, the government realized we have to interact. We have to sit together, economy, politics, and science. We have to discuss what can we do that people are more attracted, encouraged to study the STEM subjects. And there was a quite historically important symposium push public understanding of science and humanities. And it was the first time that all three entities, economy, politics, and science, discussed together and said, we have to find a solution, we have to do something. As a result, they wrote a memorandum, Dialogue, Science and Society, with 7 assumptions for science and communication. And one, for example, was researchers should not longer operate operate their science in an ivory tower. They have to bring the science to the people, not vice versa. And very important also, and this was especially a big challenge for the economy, dialogue instead of acceptance campaigns. So I'm sure you know this as well. And I was so bored when I listened to my chemistry professors who said, everybody who is critical against chemistry, you should be always aware, chemistry is everywhere. Again. So what does it mean? So we should not discuss critically about that only because chemistry is everywhere. What should it mean? So it means you should accept it, because when you don't accept it, you don't understand the reality. What is this? So it is much more important that you get in dialogue with the people, you understand their concerns, their problems, their criticisms, and you discuss it. You don't hide it. That's why dialogue campaigns had to replace acceptance campaigns. Very important. This is still today we can understand it everywhere, also in Turkey. Like a reflex. Scientists want to defend their capacity, want to say my capacity is the most important thing. but it is important to understand the other part as well. And at that moment, you people feel much more accepted. And when people, or when also scientists do not talk always, when they are also listening, very important, and getting criticism, and do not understand criticism as something bad and evil, but the opposite, to understand, wow, at that moment I can grow, I can maybe arrange my scientific topic, or at least the communication of that. At that moment, the first step is done. So this is in fact something what happened, and therefore they made an annual campaign, in fact founded by the Ministry of Research and Education in Germany, together with the German Physical Society. It was the Year of Physics, and it was so successful that we could directly understand after 2 years the numbers of student beginners increased. After 2 years already, and this was also, especially for the Physical Society, very important. You know, German Physical Society is, by the way, the biggest physical society of the world, according to the members. So I'm a little bit bad. So white hair professors. So male and very old. So, and what should be the motivation for young people, especially for young women, to go to this society? And because of this campaign where we made science festivals and so on. So I was deeply involved in this because I worked at that time in an agency for science communication. We developed these kind of science festivals, and at that moment we could directly see the age average of the members in the German Physical Society decreased as well. Yes, we did our job. We were really a little bit proud, you can imagine. So, and this is in fact what we wanted to do. But the other thing is, and this is what so often is neglected, and it is very important as well. We didn't have it as it was not a defined goal, but what we realized is it changed also the kind of scientific cultures inside of the community. Really interesting. So the people at the beginning it was this, so Agency for Science Communication sounds like public relations or marketing. Hell, why do I need marketing? I'm a scientist. I don't need marketing. And go away. You are from an agency. And I said, hey, I have a PhD in chemistry. So same eye level. At that moment, we said, you are going now to the shopping mall and present your topic there. And they said, why? There is nobody who is interested. Then do it in a way that they are interested. Yeah, but isn't it better when the people come voluntarily to you and so on? No, I want that you tell it to people who are, in fact, their main goal is to go shopping, and I want that you create a scenario that they can, beside their shopping tour, get informed and entertained with science. And they said, ooh, so we insisted so much, and we had, in fact, the support from the ministry, and so on. We said, here, you go to there. And after a while, they said, hey, wow, this was interesting. This was so amazing. I never expected so much interesting questions from ordinary people and so on. And it started a project, the kind of perception that communication is not something what contradicts your work. It is something what supports your work and your motivation to work on that. This was, in fact, something where we were so happy when we realized that these kind of effects, what we didn't have on our schedule, it was not the target what we created, but to understand this has, in fact, on both sides, only positive effects. This made us really, really happy. Yeah, so the question is, so we created science shows, we brought science to the stage, and of course there should be also lots of effects. So this is what you, I'm sure, all know. When you have some now I don't know the English word. It is little particles like flower particles. At that moment, when you blow inside, at that moment, you have a very big flame, like an explosion. So these kind of things are, of course, important. It is a quite simple sciences, but you need a little bit show, and beside you can give really answers and introduce quite complex science on that. So how, what is,
sorry, can I ask a question?
Please.
I was curious, what kind of topics did they talk about in the shopping mall? I mean, because I'm trying to imagine how was the environment like, atmosphere in that kind of situation. So did they do some experiment, or did they talk about how relevant matters?
Thank you very much for your question. They didn't make school experiments, absolutely not. They talked about their research subject. One of them, for example, explained this, how do you call it, electron nearest tunnel microscope. How does it work? So how they explained the certain crystal structures. How can you understand that? How can you get the information about the crystal structures with help of X-ray? These kind of information. So really high sophisticated physics, not simple physics. They talked about their research topics, and it worked. And I give you some minutes later, I give you an example that it works. In fact, you can believe me, you can do it with all kinds of subjects, with all kinds of subjects. It's only the question how and how do we develop. And this is what I would like to show you. So first of all, the main challenge or goal is scientists should attract the audience. Very important, very simple, but it's sometimes a quite big challenge. And how big this challenge is, and in the context of Zeynep's question is, so I don't know who of you knows what a Higgs boson is. Super.
It's a field particle.
Again, please.
It's a field particle which causes mass, I think.
Wow. So, and who does not know anything about that? Maybe heard about that, but it is far away and definitely did not understand it.
You can use the no or yes options in the participant.
Okay, not so important. But honestly, I understand it a little bit. But it is really, I don't understand everything. What I understand, what it is. So good. Thank you very much, Nihal. It is you are really honest, and the other one are too shy. Cowards. So, but let's say the very most, let's assume the very most of you have no idea, or at least do not understand that. So how can we explain that? So what we understand is Higgs particle is obviously something what we need, because according to the standard model, we know that there are certain elements. Here, so the standard model of elementary particles, we have quarks, leptons, and gauge bosons, and in fact, they are creating. In fact, they create together the proton. Let's say very simple. Please apologize. I apologize when I, as a chemist, explained it a little bit too fuzzy or not really completely correct. The problem is, the mass of a proton has the mass unit 1. It is something. So, and when we look at the particles, elementary particles, we know they all have the mass unit 0. So, and I think from the mathematics, we know 0 plus 0 plus 0 plus 0 is definitely not 1. So how can it be? What is there? How can it be that it has a mass somehow? So, and then Peter Higgs was the first who said, maybe there is another particle. And everybody said, yeah, this is so great. This is a good idea. I never imagined there's a particle. And because this was so unbelievable revolutionary, they said, okay, then we call it Higgs particle. And they calculated, and it fit very super to the standard model, and perfect. So it was 1964. So problem, predicted, but not found. Very long time not found. So when did they find it? In 2012. So in 2012, you know, there is in Geneva a very big, large hadron collider. It is in the research center CERN, and they had now the techniques, the machines, they were accurate enough that they could make experiments which could confirm that Peter Higgs was right. And it was in the year 12th or 13th of July 2012. So they Fabiola Gianotti and Joseph Ingandela, they were the representatives of the most important experiments, Atlas and CMS, invited audience, and you see that they are, wow, they are smiling faces in the background. You can directly understand also. And this was such a big event that they made a live broadcast to Melbourne, to the International Conference of High Energy Physics, and you see standing ovations. So they look at the screen and standing ovations. What did they see? Obviously the Higgs boson. Have you ever seen the Higgs boson? Who had already seen a Higgs boson? You have seen a Higgs boson. Okay, and the others, no one? Would you like to see the Higgs boson? Yes. Okay, then I show you. And I want to do it, of course, a little bit. Oh, we make a countdown. 4, 3, 2, 1. And yay, Alperen. Thank you very much. You support me. You're on. Ta-ta-ta-ta-ta-ta. Where's the standing ovation?
Whoa.
I saw the Higgs boson. I'm so excited. Mert Gencer, Burak Aslan, Elif Su, are you excited? I don't hear you.
Yes, sir.
You are. Why are you excited? So what do you see? It's great that you're excited. What do you see? What do you understand from that?
Not much, honestly.
Not really, no? So as far as I know, this is the Higgs boson. This is something very exciting. So this is quite easy to explain. So of course, to be really sure that you found something realistic, that something accurate, means you need, of course, an experiment or two experiments which find it nearly the same way. No? You can see the curves are quite similar and so on. They said, yeah. As far as I know, I'm not really sure. This is the Higgs boson. This is the exciting situation. Ooh. So this is the Higgs boson. In fact, I guess, I'm sure, honestly, you expected something like this. No? You look with a microscope and there is a kind of particle, has an H on that and says, I'm the Higgs boson. Unfortunately not. We see like something like this. So, science communication. Wasn't it great? How did I present it? So you understood everything because I showed you an information graphics. Not really convenient. No? So now the question which Zeynep asked, in fact, indirectly, at least indirectly, how can we manage this? How can we manage the situation that the people understand at least a little bit about what the Higgs boson is? We need stories. And believe me, for all subjects, you can find stories to explain it. The more complex it is, of course, the more fuzzy the story has to be. You never can expect that you tell a story in a suitable way and everybody understands even the little details about the Higgs boson. Absolutely not possible. But what you want, at least, is that you get an idea about that. How can we do this? We create a story, and there's a very famous story called Alice on the Cocktail Party. Have you heard about this? Alice on the Cocktail Party. That means, in fact, I have a little cartoon about that. Imagine there is a cocktail party. People are chatting here around and talking, and since they don't know each other so good, it is a party where are not so many cliques at that moment. They are statistically somehow distributed in the room. And there is a door, you come inside, and on the other side of the room, there is a cocktail bar. Now Alice comes inside. Alice is Thursday. She's in fact not really interested in the cocktail in the party, but very much interested in the cocktails. So in fact, she wants only to go to there, take a drink, and go away. When the room is empty, at that moment, easy, going inside, have a drink, go out. So the problem is Alice is very beautiful, very, very beautiful. So what is the effect? Especially the male guests, the man, for example, Asaf directly asks, "Hey, may I tell you I'm Asaf? May I offer you a drink?" Alperin says, "I'm sure here, but I insist. I definitely want to be the one who has the first dance with you together." So you can imagine at that moment it is for Alice really difficult to go to the cocktail bar. So it means at that moment, because of the interaction of the people, of the attraction of the people, it becomes, you have the feeling, you really feel like you are walking through honey. And this gives you a little bit an understanding how you can create a mess only because of the interaction inside between persons. And when you imagine this is the Higgs field, at that moment you have to have you get the first idea about how the mess is created. Although we are not talking about fat men, bald men, thin men, we don't talk about mess. So it is absolutely not important what is the mess of the people. It is only important about the attraction. This is, of course, and I apologize, the physics segment, oh my God, this is so fuzzy, this is so incorrect, and so on. I apologize for that, but at least you get now a first understanding, a first idea from that. And this is, of course, in science communication, enough. Now, why should someone who is not he's a bricklayer or whatever, why does he have to understand more? And at that moment when he is very much, he or she is very much attracted from that, at that moment they can talk more about that. So he can ask details. And this is the first approach. And at that moment, the step, even this theme is really complex. And really, I deal with this topic very often. I really did not understand the whole process. It is really, really, really difficult. And for me, it is enough. And when you think in these kind of categories, the more complex, the more specialized the topic is, the more fuzzy, the simpler you have to explain it. At that moment, when it is not that difficult, at that moment you can stay quite close, you can explain it quite precisely. But the most important thing in the middle point should be the story. Very important. And yeah. Oops. So, so the usage of narrative elements are very important. Science communication is not only the transfer of pure facts, very important, even in, so we are talking about evidence-based subjects, this is for sure, this is science, but it is not a transfer of pure facts. It is also a question, we have always to think about why do we want to know that? Why is it important for me? Why is it relevant? These kind of things are very important to tell. And as a consequence, we have, and this was especially in Germany, very important to understand, science is not less serious when you present it in a humorous way. Very important. And at that moment it works. So it should be a mixture of education and entertainment. And So according to the message, you have to strike their heart to move something in their head. If you don't strike their heart, you lose them. You don't lose them, you don't get them. So this is in fact the most important thing. First, you have to be attractive. At that moment, the people are able to get the information. So which kind of events are useful? Science exhibitions, science festivals, science shows, science slams or fame labs. There are lots of different kind of ways, TEDx talks, whatever. There are lots of different kind of ways according to the target audience. So, and what we now in the last remaining, yeah, can I get 5 more minutes? Is it okay for you?
Of course, hocam.
Yeah, super. So what we talked about is public understanding of science. People have questions and want to understand the science. This is in fact something very important, and I think 30 years ago, nobody expected that you are able to make science shows that you have in fact an audience like a pop festival. This is the evidence it works. So, but it is still to explain. The scientist is the clever person, and let's say a little bit in a bad or simple way, and the audience is the stupid persons who need the information. But this is in fact a very important step. And as I told you, this works only when we understand science as part of our cultures. Because when we understand it, that it can be part, you can compare the communication like a pop concert, like a museum's visit in a museum, like whatever. At that moment, you understand what science is. Otherwise, it is always far away, and nobody wants to deal with this when they are not motivated to study it. It works. Science. And very important, science and entertainment are no contradictions. These are all pictures what were from a show what I developed with my teams several years ago. And now I come to a point where we leave the basic public understanding of science. We have to motivate them, or that they can discover the joy to ask. The joy to ask. At that moment, the process from only listening to be active partners becomes starts. This is very important. And at that moment, so at that moment, they develop, they understand the joy, discover the joy of participation. And very important in this context is we are still living, and although there are so good concepts, how to integrate this, how to enable gender equalities, we are scientifically we are still living in a man's world, and this is what we have to overcome. This is very important, because at that moment, when we don't create gender equality, at that moment we have a problem in the we lose a very big talent, a very big typical approach, a female approach for the for innovation processes. So at that moment in fact, it is not complete. The process can't be complete when we are not able to empower girls and young women for science. This is the topic why I dedicated one slide to that, because this is really important. We need these kind of processes, and I'm very happy that at least the basic perception is there. But to this process needs a long time, that this is a normal situation everywhere in the scientific world. Yeah, and now we are talking about a very important topic, and this is very typical. This is in fact the development in science communication from public understanding of science to public engagement with science. So it means it is not only the question that you give them some ideas. Here is something, here's an experiment, you can also try it, and oh yeah, you discover it. It means public engagement with science, or citizen science means the public, the citizens, get the chance to be part of scientific developments. And I mean in the really equal way. Not only you are the one, you get informations and I tell you how to do this and then you can try to do this. No, they play a big role in this. And this is in fact, in the context of sustainable developments, very important. This is the only very theoretical folder what I would like to show, but it is important. You remember I told you at the beginning of public understanding of science, the political, the academic or educational and the economic system work together and try to find out how we can attract people with science. This was very important, but when we think in sustainable development, we have to include the public, according to this model, the media and culture-based public, and the natural environment itself inside as well. And we have to understand there is a knowledge, the circulation of knowledge, which is absolutely important to regard the knowledge, the know-how of the different systems as equal. When we always think there is a hegemony, at that moment it doesn't work. At that moment we are never able to create sustainable innovation processes. So it means everybody has know-how, contributes in a pool of knowledge, circulating knowledge, and they are taking from this knowledge know-how. So in fact, the giving knowledge to the society or to the system and taking the knowledge from that, this enables that all systems enables individual innovation processes, and only the sum of these innovation processes makes the system sustainable. Means public, in the future, the public needs to be part of the agenda setting of science. It sounds really crazy, but in fact, we need the situation that everybody in all these kind of entities, so politics, of course, they say they decide which research will be supported by money. So they give, of course, influences on the educational system, the economy as well. So they are normally the one who are taking the gain of innovation processes in the academic world, and of course they are sponsoring these things. But we need to understand that the natural environment and the media and culture-based public has to be part in the process of the agenda setting. If we don't do that, at that moment, we have no chance to create sustainable innovation processes. And at that moment, I'm really pessimistic. I say we have no chance to combat the climate change. So this should give you at the end a little bit an understanding that science communication is not only the question how people understand science, not just to be good informed. It is also important that we enable public engagement with science to combat really the big problems of our world. So yeah, ladies and gentlemen, I come to the last slide. The last slide is advertisement. I just published a book. This will be issued in Peter Lang, I think latest in January. This is a book I was really proud of it. The first part are approaches from different science communicators all over the world, especially from Europe. And the second part a popular science text written by my students, which I taught in the last year in the subject science writing and journalism, and the quality of these kind of writings were so high that I thought this should be published and presented to the society. So keep in mind that we will have hopefully this book in the library. Otherwise, if you are interested, please buy it. And yeah, thank you so much. It was really enjoyable for me to be here. Thanks again for invitation. And now, of course, I'm extremely interested in your questions.
I may interrupt first.
Yes, please, 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 of course.
Thank you for your talk. It was so good. We have learned so much, I guess. And I would like also do an advertisement because we are here to do the science communication. And my friend just sent the links for our WhatsApp group. So we would like to have all the people who would like to learn about science besides their grades on biology. They cannot do maths or anything. We just want to talk about science. And we would like to talk in a good science communication way so that everyone can understand. So we are waiting all of you to our events and our WhatsApp group so we can have the questions.
Yeah, great, Öko, and I will support you wherever I can, because this is really a subject which comes from my heart, and according to me, it is really, really a very, very, very good idea to do this. And if you want to exchange your experience and you need me, please contact me. I'm definitely inside of your team if you need me.
We will, Hocam. And I'm encouraging you all to open your camps so that we can have a talk all together.
Someone raised hand, Ekim Kara. I think we can give.
So hi, I'm here. Thank you for this talk. It was very insightful. I have one question about science communication. I write on a student newspaper for Bilkent, and sometimes I have to present some scientific articles to public in a very more basic way. And most of the times I'm very concerned about not making a terminological mistake while presenting the issue. But as you also stated in the beginning of your presentation, when we are stuck with the terminology, it gets really boring and not understandable. However, I know that for Bilkent's newspaper, it's not a high impact one, so I don't think I will have problems. But let's to say I was writing in somewhere bigger, and if I made a terminological mistake while trying to communicate science in a cuter way, how do you think we could deal with this? Like, how can we be accurate and still not be boring in quotations? I would like to hear your opinion about it.
Yeah, thank you very much, Ekim, for your question. This is really an important question, and I would like to answer you in a way. May I ask you first from which faculty you come, or from which subject, from institute?
I'm a molecular biology student.
Okay.
I'm a fourth-year student. I write in the science and technology department.
Yeah, super. So the first situation is write always about things what you really know. This is for sure. And if you write about my microbiology, I expect and I know that you know what you are writing about. So at that moment, but even if you become, for example, a science journalist, at that moment, normally you do not write only about microbiology. Sometimes maybe you get also, you will send by a newspaper or radio or TV channel to Stockholm, and you should write about the Nobel Prize, which is just announced. Then at that moment, it is maybe a subject what you don't know. At that moment, of course, you have to get the basic information. This is for sure, and I'm sure this is something what you of course know. The second thing is you have to decide who should read it and what the target group of the newspaper or of the science magazine or whatever, and what in fact can you expect that people are first of all to tolerate and to understand. At that moment, it is really a very complex theme, which is outside of our life world. At that moment, you have to be very fuzzy, and being fuzzy doesn't mean that you are that you tell nonsense. It is only you leave the terminology what you are used to, and you bring it more in the context of something what people understand. At that moment when we have, like, for example, in the Nobel Prize of this year, so of physics, great, easy. So it's about black hole, yay. So this is, everybody is interested, and you can tell quite easily what it is about. So in medicine, hepatitis C also, of course, everybody knows somehow about hepatitis. Maybe they don't know ABC. Why is it ABC? At that moment, you explain it. This is, for example, a situation where what is your target, your goal, this is what you have to do. You have to explain, we know about hepatitis C, B and A, and what is new on that, and what is in fact the interesting situation on that. The same with CRISPR-Cas9. I'm sure you all say, yay, CRISPR-Cas9.
I actually did write about CRISPR for the newspaper, for the Nobel Prize.
Yeah,
but it turned out more complicated than I thought it would be.
Of course. Of course. So, but even if you call CRISPR-Cas9 the genome scissor, at that moment you directly create a kind of analogy. You have a symbol, you something cut. So you cut something. These kind of things helps very much. Now, use always words where you can expect that it is very close to the life world. Now, and when you, like in the Higgs boson, but is so far away from the life world, at that moment you have to create stories which are related with the life world. And about Alice and the cocktail party, at least, even if you don't like alcohol, at least you have an idea what it is about. So the other thing is, and this is, according to me, the most important thing, find your own style. There is no law, no higher law which tells you this is a procedure which is good science communication and this is not. So, and this is in fact the first approach is, if you want to talk about science, think always in the situation, how can you attract the people with this? It means you should reflect first of all yourself. So, and the good situation is, if you go to a party, and how would you try to attract other people from your person? Some people are very comedian-like, they are talking, making jokes, and everybody is so happy at that moment. Maybe they are very good in writing comic, funny texts. If you're not a funny type, never try to write a funny text. It doesn't work. It will fail, definitely. But there are so many options. So maybe you are much more, because of your passion, what you are taught, or you are very good in creating analogies or metaphors or whatever. This is so wide. So at that moment, when you know how you are able, what is your strength in writing, at that moment you are able to attract the people with your texts.
I understand, thank you. And one more little question, if we have time. It's time about when we are about drawing or illustrating those comics about science that you showed. I assume they go for a wider audience because they are shorter and they just need one glance to look at. I know there is no definite answer, but what do you think that is the responsibility of a scientist to be as accurate as possible while representing the thing on the illustration? Because I really don't like misrepresentation of data, but sometimes it's inevitable, and I'm really looking for like a really fine balance with it. Like I'm not expecting an answer right away, but I just wanted to hear if you have any opinion on it.
Yeah, I understand your question. And by the way, I remember that I forgot to answer one question. The question of accuracy. How can you be sure that something is right what you what you wrote? I can answer in the same way like the question you have. In fact, popular science writing is something what you never should do completely alone. No? So it means at that moment you write a text, like in fact, like peer reviewing. No? Give it to people, have a look if they understand it. Maybe have discuss it with your peers if that what you are writing about is accurate enough. When it is a subject what is not your own research subject, at that moment it would be good when you ask an expert of that, no? That he can say, check, you are right. So this helps very much. And at that moment, I'm absolutely sure when you deal with this in a longer way and you get experiences, at that moment you know about your strength, things where you have to be a little bit careful. At that moment you get, in fact, a little bit the peer review, the confirmation that everything is right and so on. And the process, these kind of process become not that challenging like at the beginning maybe.
Okay, thank you very much.
Welcome, Eke.
Also, can I ask something?
Please, Silma.
Yes. Have you started to think about the importance of the scientific communication because of the climate change or something else?
This is a nice question. In fact, I can't remember how it was completely. First of all, in fact, it was both at the same time. So I don't know if you know the Green Party in Germany was founded in 1979.
I don't know.
Doesn't matter. So Germany was quite early in the perception of environmental problems. I was very much engaged, not politically. I'm not a political type. I'm more a scientific type. So I worked on a ship which made drink water analysis, and we went along the rivers and offered our services and gave somehow little informations and so on. So this is what I did. But in fact, the first time, so it is not, I didn't change the subject to science communication because I was not happy in chemistry. I liked chemistry extremely much, and in fact, I was a little bit proud of my examiner. It worked quite well, let's say. So, but during my PhD thesis, I met a guy. I can show you the picture of him once again, and maybe you know him from this one. This is Ranga Yogeshwar. Do you know the little movie, the clips Iki Dakika Bilim? Have you seen this in NTV? There was, I don't know if it is still running.
I'm not sure, but you might have seen it.
Yeah, no? And this is in fact the guy who does this is Ranga Yogeshwar. He's a very close friend of mine now, and I met him when I was during my PhD thesis. He was a very big science communicator at that time already, and he directly said, "Yeah, if we wanted to have him for a talk show," and he said, "Yeah, of course I come, but before I come to you, you come to the radio channel, and I will tell you talk with you about science communication." And then he did it. We talked really extremely long about that and what is necessary, how do we do that, and I said, this is what I want to do. In fact, it was like this. And at that moment, it was anyway the situation. I told it a little bit funny, and it was also funny. So, but I really felt annoyed that nobody understands me. So I was in my youth, I was hitchhiking really a lot, and it was always when I was picked up, the driver drove. It was in fact like this. Drove and asked, "What are you studying? Are you studying? Mm-hmm. What are you studying?" Chemistry. I was so bad in chemistry all the time. This was always the situation. And then when they never asked me, "Yeah, what are you doing?" And in fact, a little bit, I was happy that nobody was asking me because I felt, it's really not easy. I can't explain it to someone. I was not able to explain it to my mom on the kitchen table, and therefore I felt a little bit, I really understood it as a deficit. And that's why I thought, when it is possible to create a profession from that, to create a job from that, at that moment I want to do it. And in fact, I had really lots of luck. So that, in fact, I was graduated near 2000 at that moment. The people understood this, so there was a budget from the government. They said we spent money on that, and in that moment I had the job. This is of course also important.
It was a nice story, thank you.
Yeah, I'm really happy about your questions. So please don't be shy. If you have questions, I'm willing to answer it.
I had one question.
Yeah, please, Zeynep.
I'm sorry because you passed this slide for a long time ago, but in the slide of the Alice cocktail party, so we saw.
Should I show it once again, or is it okay when you only talk about that?
You can show it. This will be great. Thank you. So I saw like two sad faces, right, in the first picture, and then they become happy. So maybe you said this before, but I couldn't understand the reason behind it. Like, why? What is the meaning of behind these two faces?
In fact, the faces do not have any deeper meanings. It is only, it should show a little bit. At that moment, when you create stories, it is very easy when you create a kind of human-like beings, and therefore, when we only use faceless particles, it is difficult to show. You are absolutely right, and this is, in fact, maybe a weak point on this cartoon. Let's say the faces or the beings are a little bit inconsequent. When you, for example, can you see my mouse? Yeah. So when you see here they have not only faces, they have also arms and legs, very cute. Here they don't have it again, and here they either. So it means it is not really consequent. So don't. It is. There is no deeper meaning inside. This is what we wanted to show with this cartoon, of course, is somehow the attraction. So we have here on the first frame. Yes, statistically distributed particles which are not attracted from something. And here, because of the beauty of Alice, there is a big attraction, and this creates, in fact, the field effect. That's all. It is, of course, very fuzzy, on purpose, very fuzzy, and it is, yeah, but it is interesting. I used this for research as well, and many people were really confused because of the inconsequent things. And this is, in fact, also one thing what I can, as an advice to Ekim. So you do whatever you do should follow a certain logic, because when there is something what is illogical, at that moment you create confusion. Obviously, for you, Zeynep, as well. So it is absolutely clear. It is, you understood the weak point of this cartoon.
Thank you. And also, was it about the Higgs boson, right?
Mm-hmm.
Yeah.
This was about the Higgs field.
Okay, thank you.
Welcome. Yeah.
I can make a comment. Rather than a question, I was gonna actually make a comment.
Yeah.
Yes. Which I also want to hear your thought on this. My comment is about the story that you told us at the beginning, the one about the giant gets smaller as one gets closer to it. I really like the analogy, first of all, that you made with the appearance of a scientist to other people, but I also wanted to emphasize that I realized that is also common among scientists. A chemist might seem as a giant to a physicist sometimes. And even in physics, a theorist can be seen as a giant for an experimentalist. So during your talk, I thought about it and thought that it is mostly because of the terminology that people in specific areas use to communicate with each other as well as to do their science. So in order to break it down, we need to if there is a word, something like that, but story lies, like our work, even for telling someone who is already a scientist, but in different areas. So I'm sure that you also had encountered like this kind of things.
First of all, from which department are you?
Physics.
Physics, cool. So in fact, it is always a question, of course, of with whom and why do you want to talk with chemists, for example. You brought the example of chemists. So at that moment when it is somehow a peer talk, at that moment, of course, you should not be too fuzzy, let's say, or too popular. It is no need. So by the way, I studied chemistry, but in fact, honestly, I was much more affected by physics. I only studied chemistry because I liked it as well, and I was at school better in chemistry than in physics. But because of that, my research topic was about physical chemistry. So this was a little bit, physics was inside of mine as well. So in this context, what I want to say is at that moment when you are on a conference, you have an overlap, you have a topic what you want to talk about, and you feel that chemists are giants. So you don't, in the meaning of you don't understand them. They are talking about something what sounds for me like Chinese language or something like this. At that moment, something is wrong, of course, in the peer discourse. This is for sure. So, but this is in fact another level. So, of course, a good scientist knows that even if you are on a world conference of, I don't know, elemental particle physics at that moment, it is absolutely clear the research topic where I am the expert, it is quite improbable that there are other experts in this as well. I have knowledge about that what nobody else has on the world. You really can have these kind of understanding, self-confidence, because it is like this. So it means even among physicists, you will have a research knowledge about a research topic, but nobody has. And at that moment, you have to have a good balance to explain it in a simple way that everybody knows about it. But on the other side, also not too simple that people that the peers are not bored, because you don't have to convince them that this is an interesting subject. These kind of things, they are convinced. So at that moment, the challenge is something completely different, and this is a little bit outside of a science communication discourse. Although, and this is why I like your question very much, it is of course also a question. This is always the question: how can I enable that the other parts understand me? No, and this is definitely for sure.
Yes, thank you very much for your answer.
Welcome. Yeah, then I give the floor back to Öykü or to Asaf.
I would like to ask some questions or
Please.
talk. One topic is conspiracy theories. I would like to add to Higgs boson. When the experiments on CERN was held, our people in Turkey, I remember I was at, I don't know, in high school? No. Okay. We were all talking about there's an experiment held in somewhere and the world is going to blow off. And we didn't understand, and we are talking about some conspiracies. And today there are some vaccines for COVID. There are lots of work, and people are saying that the scientists actually did this virus for some purposes. And we would like to fight for these conspiracy theories. And how can we do this without it's hard to talk with the people because they don't want to understand. but we are just trying to, because it's hard to, they cannot, how can I say this? Conspiracy theories are not based on some real things. So it's easy to make people believe in this. So how to break these?
It's a really important question, and this is also a very interesting topic, no, which we what you should or I would like to discuss also where we talk only about conspiracy theories, because it is of course a complex one. Simply, so just to give some simple answers is, first of all, we all know, I don't have to explain it to you, but we have to explain it to the world. Science is always evidence-based, not more and not less. So at that moment when conspiracy theories exist or is generated or arise, mostly when it is mixed with beliefs, like you said as well. So at that moment when people are very much when they are strong believers in certain religions, or mostly conspirative theories exist at that moment when you have the feeling, you create a kind of self-understanding. I'm the only one who knows about the world. You don't. By the way, conspirative theories are very male dominated, male ones. So the typical situation, in fact, I have to explain you the world because you can't understand, but I understand. I know who are the alienated people and so on, and I understand it from the eyes. And in fact, if you still believe that the Earth is a globe at that moment, sorry, it is a plate. The rest is just, in fact, optical effects that you have the feeling this is a globe. Now, these kind of things happen. But at that moment, the only thing is what we can do is, first of all, to say, give me the source, where do we have these informations? And if you are the one who are the searchers at that moment, give me clear understanding of that, what you said. Then at that moment, you can discuss. These kind of things is, first of all, should be only discussed on the evidence base. And so I talked now about the, let's say, a pathological way of conspiracy theories. But for example, my kids likes it also very much. They read in the, this is also a typical situation, the fake news. So sometimes conspirative theories are very entertaining, extremely entertaining. So therefore, they read it and they, at the kitchen table, they discuss with me, here I heard that in fact this is not, my kids told me as well, yeah, this is in fact made in the laboratory just to get advantages, to weaken the economy of someone. And said, yeah, but it is a global situation. And I directly said, give me, where did you get it? Yeah, they said, yeah, who is they? The scientist said, which scientist? Give me the source. And at that moment, they say, yeah, okay, I can't discuss it with you because I don't have any source. I said, come on, most important thing is have a look at the source, check which kind of thoughts they are. Are they serious? Are they not serious? Of course, sometimes you can't understand, but at that moment, at least have a look who is in the editorial board or whatever. This, we have so many opportunities. So, and we as scientists, our responsibility is to show the people this is in fact nothing but a belief, and therefore don't discuss scientific topics on this level. The rest is in fact, so we have to be aware that we have also only limited influence, especially when we think in the context of social media. So this social media has such a big power, because there are so extremely many people who are writing there inside. And the same situation, especially in the context of pandemic situations, is I heard so many interviews from medical doctors, and they say, yeah, I'm in fact an expert because I'm a medical doctor. But when he is an orthopedist at that moment, I can also say I have 2 doctor titles. I'm the specialist on the pandemic. It is nonsense. So we always have to know, is this medical doctor really a virologist? Is he an expert on that, or isn't he? And otherwise, in fact, say goodbye. No? The only thing is, what we can hope is that these medical doctors at least have access to sources which we don't have so easy. No? So, and at that moment we can ask, no? But it is at that moment also important to know here which kind of sources did you use. Very interesting is, I think you know the discussion about hydroquinone. And I tell you a story from my private life. There was a wife of a medical doctor. She took as a prevention, she was not ill, as a prevention hydroquinone. I said, what? So why do you do this? Yeah, I heard in Hacettepe, the medical doctors take all hydroquinone. I said, well, this is a reason? First of all, are you really sure? Yeah, I'm absolutely sure. And then I say, then give me, in fact, please, the source, where it is written that you can use it for preventive, as a preventive medicine. And then she sent me lots of articles, and these articles were scientific articles, but there was clearly written inside that there are so many serious side effects, and that that there is no evidence that you can use it as prevention. Unbelievable. And I said, hey, didn't you read this? He said, yeah, a friend of mine translated it to me. I'm not able to talk in English. This is the situation. So, in fact, it is always something to do, as a media scholar, I would say it has something to do with the trust in sources, but basically evidence. You always have to force them, give me the evidence of that, what you are talking about. And when they don't give you the evidence, they say, sorry, I'm out. This is, in fact, something what I can't regard as serious.
Sorry, I missed it. What was the thing that the woman used? I missed the name.
Hydroquinone.
It's a medicine that's used in malaria cases.
Yes.
And also, I have a question, if Öykü allows me to ask.
Please.
I was a little bit late because of my research. Sorry about that.
No problem.
And I would like to ask, you said that evidence is important, but somebody can also alter the evidence for their task. For example, we see that many of the flat earthers show that, like, the Earth is flat based on showing their articles that say Earth is flat. How we can face those people in this in the light of science communication?
It's a good question, and it is not easy to answer. First of all, when someone shows you a scientific article that the Earth is flat, at that moment you only can answer them with article which is so clear, and which you, for example, when the Earth is flat and you go with a satellite through the Earth, at that moment you can go around here, and at that moment you have the feeling it is flat. No? But at that moment when you go like this, at that moment you have no chance to understand why is it flat. No? So at that moment it is clear it can't be flat. No? When you can go in all directions and you come always to the last point. No? This is, for example, an argument, I would say, an easy argument. And when they say, yeah, but these are in fact only optical irritations, yeah, after a while you have to, it is only the situation, yeah, show me a little bit more about that than only the article. And I'm in doubt that that these kind of articles are published in scientific magazines or journals which we can regard as serious. But it's really, it's very difficult to answer, of course, in a way that it depends a little bit on the context and on the situation. And of course also the style of communication. This is for sure, and it's not easy, and especially in the context. And I appreciate very much that this is a topic what you have on your agenda, because at that moment we have to face the problem. We have to solve somehow the problem that the power of the social media becomes too strong. And it is not only the scientific topics, but also the scientific topics which are discussed so heavy and in such a wrong and dangerous way that I'm sometimes shocked. And the topic what I'm very much interested in is in fact the topic of entertainment. I showed you the aspect and I made a little bit advertisement, be entertaining, so that the people like to listen to you. In fact, after a while, and when you go in a deeper context, at that moment you see the aspect of entertainment in the social media is extremely high and sometimes risky. And so when you, for example, understand why is a president like Donald Trump elected, why is a kind of Viktor Orban elected in Hungary, why is in Germany the right-wing party AfD so strong, and so on. They have always one tactic. They want to entertain people with their rage, for example, like Donald Trump, or with some certain topics, and then everybody's shocked and say, hey, how dare you, these kinds of things, and the press is talking about them, and one day later they say, sorry, I didn't mean it like this. And at that moment, they had the public relations at that moment. And so it means at that moment when also a scientific topic is very much entertaining, and to tell there are alien-like beings on the earth is something, of course, the science fiction. So we like this. This is entertaining to think about that. And this is, in one case, a burden for science. So we have to use entertainment, of course, on purpose, to understand, to attract people with science is important, of course, but on the other side, and this is what I would like to understand, this is one of my research topics, is how can we combat pathological entertainment, let's say. So this is really not easy to understand, and since the media technologies, the media platforms change so fast, so it is really difficult to make certain media studies about that. It's really a problem. But a society, like your scientific communication society, is a perfect approach. I really, really appreciate it that you do this beside your studies.
I have one question.
Yes, please, Asaf.
What do you think about science communication on social sciences? Because we mentioned sciences, I tend to think about the nature sciences, such as physics or mathematics. And in my opinion, I believe learning something in social science is harder than the nature science, because you need to know the before or after the events or phenomena. In physics, things doesn't work like that, right?
Yeah, it is interesting that you say that you regard, when I understood you right, that you regard the communication of social sciences as more complex than STEM's communication. I find it the opposite, because of social sciences are almost, there are of course also very complex and abstract theories, like for example the system theory of Niklas Luhmann or whatever. There are also very complex things, but in fact the research questions are mostly quite close to the life world of the people. So when I, for example, when I talk about to my parents that I'm now dealing with social media, at that moment they understand what they were. The first question was, what? But you studied chemistry. Why do you do these things? Didn't you find a job in chemistry? So, but at least they understood it much easier. And the very most of the research topics, when we talk about conspiracy theories, there are very complex and detailed research about that, but it is always very much related with the society. This is per se, per definitionem, social sciences. And that's why I regard science communication in the context of STEM subjects as more challenging, let's say, because we are dealing with subjects which are since, let's say, 150 years going away from the life world. So when here's the science, here's the life world, so we have to fill a gap which is really high. This is really, first of all, we have to talk about the science. Which kind of science do we use in that? So when we, for example, talk about NaCl at that moment, all the scientists and people who remember from school knows this is nothing else but salt, what we are using for cooking. But why do we use that? We have to learn that. The way of getting the knowledge of that is so much different and much more on an abstract level that it is, according to me, more challenging. So at least my research interest is about science communication in the meaning of natural sciences and technology and engineering, because to deal with these topics is complex, let's say.
Thank you.
Further questions? Otherwise, I would like to give you an announcement. So I give the course ComD 335. I can write it in the chat as well. I give it normally in, this is science writing and journalism. So this is what I mostly give in the fall semester. I don't know exactly if I will give it in the next fall semester, but have a look at that moment. And if active, I like to invite you to go to this course if you are interested in this thing. And I was extremely happy 1 year ago, the rectorate said, yeah, we want to have communication courses for scientists. Please create us a curriculum. And my colleagues created a curriculum, and it will be executed the first time in spring semester. It will be the course ComD 203. This is the course Media Studies 1. This is definitely always executed in winter semester, but this is more for communication scholars and communications scientists. But in spring, it's a pilot project. This spring, there will be a pilot project that I give this course especially for scientists and engineers. So I deal with in the same curriculum about semiotics a little bit about film studies, science in film, about representations and so on. So you will learn the basic skills, tools, and so about communication studies, but in distinction to the course what I give in autumn, I definitely will give you, I will choose topics which are closely related with science communication. So I can't overcome the curriculum. I don't want to overcome the curriculum because I want you to understand the tools, what we use, the basic concept, what we use. But of course, I want that you are able to apply this on science communication. So if you have time, if you want, you are more than welcome to take this course. ComD 203 Media Studies 1, I guess it's called. Yeah, ladies and gentlemen, it was really a very big pleasure. I hope you didn't feel a little bit annoyed that we talked longer than I got informed or instructed by Öykü. We talked about 1 hour, now it is nearly 2 hours. I had really pleasure, and I hope you as well. Thank you, Öykü, once again for your invitation. And yeah, if you have questions, write me a message. I'm really, it's a pleasure for me to answer that. And sometimes I have a big workload, and I cannot answer maybe directly always. But at that moment when I don't answer, please don't think that I don't want to answer at that moment. Insist that I answer, and then I will do it definitely. And again, my offer, if you need support, advices, consultancies inside of your society at that moment, I'm very happy to help you.
Thank you, Ecem. It was very nice to meet you, and we would like to talk with you with other issues. And I would also want to talk about Science Festival, because it was a really nice concept. I've heard that from Veli Vuraluslu, as we said, the one inspiring person for us. He wanted to make a science festival in Turkey. He asked for our recommendations, but we are not, we have lots of ideas, but we need some advices also. Why cannot we do such a thing? That's the question. And we can all get our ideas together and try to do something different.
Yes. Yes, they're very, very important. This is, I only give you a very short statement about that. When we talk, and this is the concept of science communication in Turkey is very much related with science education. When we talk about science communication, according to my, and we want to create festivals, we should forget education. We should only think about communication. Means we are not at school, we are not in a situation where the people are anyway caught, so they cannot escape from that. We are talking about situations where the people have to come voluntarily, like in a pop concert or whatever. And when we want to reach situations like this, this one, at that moment, we have to think according to communication, not according to education. And this is what we can discuss, of course, more detail, because in these kind of concepts, I'm very much experienced. I have quite a lot of experiences.
Okay, we will get in touch with you again, of course.
With pleasure. Good, yeah, ladies and gentlemen, if you don't mind, I say goodbye, and hopefully we see us again, and have a nice evening.
Goodbye, Ecem.
Bye-bye.
Bye, everyone, and welcome to our society.